Good morning. Okay, so today we're solving rationals, and you will see that it's just going to put together our skills for adding and subtracting rationals and the skills you learn for partial fraction decomposition. Okay, so the first thing I'm going to ask you are, what are the two cases we need to check when working with rationals? This goes back to week 1. What are things that we have to watch out for when dealing with rationals? What can't be? Okay, be more specific about negative numbers. Okay, even root, you cannot have a negative number. So, like, you cannot have the square root of a negative number, okay? Even root, sorry, I can't spell today. Even root, no negatives, right? Because you can't take the square root of a negative number. You can't take the fourth root of a negative number without it being imaginary, and we're not dealing with imaginaries, okay? What is the other rule that we focused on? Excellent, madam. No zero in the denominator. Awesome. Okay, cool. Okay, we are going to use those two rules to make sure that once we solve, we don't have any extraneous solution. All right, looking at the first problem, what do I need to do? What do I need to do? I need a common denominator, which is going to be 40, which means this gets an 8 and an 8, so 16 over 40 plus 35 over 40 equals y over 20. Okay, so believe it or not, you're solving rationals as your warm-up before I gave you any instruction, but you used your skills. So 51 over 40 equals y over 20. There are two ways to solve this. Cross multiply. Okay, when I cross multiply, I get 1020 equals 40y. And when I divide by 40, cancel the zeros. So 102 divided by 4 is 25.5 is my value of y. Okay? All right. Another way you could do it is from 40 to 20, what did I do? I divided by 2. What I do to the bottom, I must do to the top. 51 divided by 2 is also 25.5. Okay? The easiest rationals to solve are when it's fraction equals a fraction. So we want to try to get it in that order. There are some that will not clean up that way, and we have to do a little bit of extra work. And that's where your work with partial fraction decomposition is going to come in handy, okay? All right, so let's move over here to this one. Okay, I don't need to get a common denominator because it's a fraction equals a fraction, so I can simply what? Cross multiply. Boom, I get 5x minus 15. And on the other side, I get x plus 2 because 1 times anything is just itself. Yes? Okay? I am going to subtract x from both sides. 4x minus 15 equals 2. Yes, I did it before. All is one step, but for some people, it's better if I show all my work. So 4x equals 17. Therefore, x equals 17 over 4. Problem done. And you can leave it as a fraction. It is 4.25. You don't have to do that extra step, but good job. Cool? Yeah. So that one up here could have been 51 over 2. All right, good? Okay. Let me pause for a second while I hand out today's worksheet. Okay, please turn to number 4 on the worksheet I handed you. Okay. So I want you to look at this, and instinctively, what's the first thing you want to think to do? Factor. Awesome. We want to factor. So what are two numbers that multiply together give me 8, and when I subtract them make negative 2? Negative 4 and positive 2. Another tip is whatever sign is in front of the middle goes with your bigger number. So we know 4 and 2 makes 8, and we know that they're 2 apart. So the negative goes, because this is negative, the negative goes with the bigger number. So the person who made the worksheet did plus a negative. I don't believe in that, so I just put subtraction, sorry. Okay, so what do you notice now? Yeah, we have a whole. We have a match. Let's go ahead and cancel it out. Good. All right, so that leaves me with 4 over x plus 2 equals 4 over x plus 4. Okay, now what am I going to do? Cross multiply. Okay, 4x plus 16 equals 4x plus 8. Okay? It can't work out. Why? What do you mean they're just too different? All right, so if I subtract 4x, I get 0 plus 16 equals 8. So 16 equals 8. Will 16 ever equal 8? No, so this one has no solution. What if when I got to the end it was 16 equals 16? No, what does it mean when I have when I simplify all the way down it says 16 equals 16? It means unlimited solution, okay? All right. Shh, please move to, I believe this is number 6. Is this number 6 on your worksheet? Yeah? Okay, so what is the first thing you notice when you look at these 3 fractions? There's an x in all the denominators, okay? What stands out? Come on. There's nothing to factor because I don't have an x squared. Why do I have to multiply? Right, they're all different, okay? Now, time out. Are there 2 that are more closely related, x and the 2x? So to make my life easier, let's put those 2 together because that's an easier common denominator, right? So how do I get, how do I get this guy over here? You subtract minus 1 over 2x minus 1 over 2x, okay? So on this side, on the side closest to me, what's left? 3 over x plus 7 equals negative 1 over x minus 1 over 2x, correct? Okay, then I do what? I multiply by 2 because my common denominator is going to be 2x, and this guy is missing the 2, okay? So then that leaves me with 3 over x plus 7 equals negative 2 minus 1. What's negative 2 minus 1? Negative 3 over 2x. Good job. Okay, and now I have a fraction equals a fraction. So what can I do? Cross multiply. Okay, so I cross multiply. I get 6x equals negative 3x minus 21. How did I get that negative 3x minus 21? I multiplied each of these by negative 3. Good job. Okay, now what do you want me to do? Combine, okay. Add the 3x. Boom, boom. So now I get 9x equals negative 21. Okay, keep going. X equals negative 21 over 9, over 9, which reduces to negative 7 over 3. I would accept either of them. Whoa, whoa, I heard a whoa, whoa, whoa. I would accept unreduced. Jordan, did you have a question? No, you good? I would accept unreduced because that's a test a field they should have tested on you years ago. Okay? I'm testing, do you know how to solve rationals? Are we good? Yep, I can scroll back up. Okay, please move to number, is this number 7? This number 7? Okay, so again, I'll be honest, I stole this worksheet from somebody, and I don't like its current state. It works out prettier if we change this to a minus, please. Change that to a minus. I'm going to make it, it's going to be a challenging problem, but this way it gives a pretty answer, okay? All right, so what's the first thing I'm going to do? Oh, wait, what's the denominator for 2? Over 1. Okay, what's the first thing I'm going to do? I factor because I see an x squared. So I'm going to give you 30 seconds. Please factor this denominator. All right, since 30 seconds is too long, what do you want? What's the denominator? X plus 3, x minus 2. What do you see? What's going on? What do you see? What do you see? What do you see? I see this x minus 2. Great. Okay, so this is going to be my common denominator. I'm going to have 5 over, leave it in factored form for now, x plus 3, x minus 2 equals the 2. The 2 over 1. What is it missing from the denominator? It's missing both. So I need to write both. Okay? This is missing both pieces from the denominator. So I have to write both. Okay? All right, the last fraction, what is it missing from the denominator? So I'm going to do x minus 3 times x plus 3 because it's missing that. Okay? So give me 1 second because there was a couple questions. So I'm just going to highlight. So this, whoops, bad highlight killer. This fraction here in the denominator, it is missing both pieces. So I had to put both pieces. This one was only missing the x plus 3 because it already had the x minus 2. Okay, question. Okay, so that's a good question. Why would I want to do this? Think back to partial fraction decomposition. What am I allowed to do now? I can cancel out all the denominators across because they all match. Bye-bye. All right. Yeah, last time I tried to say that, you guys got mad at me, so I'm not going to say that phrase again. All right. So now I have 5 equals 2 times, I'm going to go ahead and do FOIL. That brings me back to that x squared plus x minus 6, right? When I multiply, use FOIL. Okay, minus, now, I'm going to put a minus 1 so you guys remember to distribute that negative because it gets ugly when you guys forget that. So what is x minus 3 times x plus 3? It's one of the shortcuts. X squared minus 9, okay? But, all right, so now let's go back and distribute. Distribute, 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 and here I'm going to distribute. Okay, when I sorry, I hit the wrong thing. When I distribute, I get 5 equals 2x squared plus 2x minus 12 minus x squared plus 9, okay? Okay, so because this is subtraction, it's subtract everybody. And so I don't forget, I put a minus 1 so I remember to distribute the negative. If I just leave it as a subtraction and there's no numbers, sometimes I forget to distribute. So it's just a trick to make sure we don't forget. It's not necessary. Okay, now what am I going to do, guys? I'm going to clean it up. Okay? So what is 2x squared minus x squared? X squared. 2x has nobody, so plus 2x. Negative 12 plus 9 is negative 3. Great. Now what do I need to do? Move the 5. Please remember, whenever there's an x squared, the equation must equal 0 in order to solve. So minus 5, 0 equals x squared plus 2x minus 8. Ooh, what can I do now? You could do the quadratic formula, but my goodness, that's a lot of work. I can factor x plus 4, x minus 2. So that means my solutions are -4 and x equals 2. Yes? Okay. Now, we are not done. Okay? I'm going to give you a couple seconds to make sure you have all the work. We have one small final step to do. Okay, so I told you there's a final step. My two solutions are -4 and 2, okay? Now, we need to go back and make sure that none of them make a negative even root and that none of them make a 0 in the denominator. So go back to the original problem. If I plug in 2, it doesn't work. It puts a 0 in the denominator. So my only solution is x equals -4. X equal 2 doesn't work because it makes a 0. Make a 0. Good? So it's extraneous. I mispronounced that one, sorry. Extraneous. Ready to continue? Okay. Go ahead. This is number 10. I want you to give it a try yourself. I would relocate something so its fraction equals a fraction, which is much easier to solve. Oh. Okay, so here we go. Let's discuss. The first thing I saw many of you do was you went ahead and you subtracted x over x minus 5. Okay, that's fine. Give me a second. We'll check our final answer. Okay, that leaves me with, gentlemen, x plus 3 over x minus 3. X plus 5 minus x. X minus x is 0, so it leaves me with 5 over x minus 5. Now I have fraction equals fraction. Those are the easiest type to solve. That's why I moved this guy over here, because I noticed that their denominators match. Okay? I cross multiply and I get x squared minus 2x minus 15 equals 5x minus 15. For those of you who don't know how I got this side, I did x plus 3 times x minus 5. I used FOIL. You may have learned double distribute, however your algebra teacher taught you. So x squared minus 5x plus 3x minus 15. And the -5 and the 2 made, the -5 and the 3 made 2. Good? All right, so I noticed that I have an x squared, which means I have to get the equation to equal 0. So x squared minus 7x, because I'm going to subtract the 5x. And then when I add the 15, what happens? It cancels out. So x squared minus 7x equals 0. And then a lot of you froze, or some of you moved the 7x to the other side. No, no, no. If it's an x squared, it needs to equal 0. We learned 3 types of factoring. There's trinomial, okay, which if there's not a lead coefficient, I simply 2 numbers and multiply the last that add up to the middle. If there's a lead coefficient, then we do factor by grouping. Now, there are 2 types of factoring for binomials. There's perfect square minus perfect square. Is this a perfect square minus perfect square? No, this one I'm going to use. What is that called, multiply by x? What is that called? What type of factoring? What is x? What math vocabulary word? Come on. Greatest common factor. My GCF is x. So my two factors are x and x minus 7. So either x equals 0 or x minus 7 equals 0, making x equal to 7. So 0 and 7. Will either of those numbers, let me go back to the beginning of the problem, will either of those numbers create a 0 in the denominator? Nope. If I plug in 0, that works. If I plug in 7, it works. Do any of them make a negative radical? Or, sorry, a negative under the radical? No. Then we're good. Both of them are solutions. Okay? The solutions are 0 and 7. No, I didn't forget about the x on the outside. Watch. X, when I factored out that GCF, because it's a variable, it matters. If it's a constant, a new number, it doesn't. So I set this factor equal to 0, and I set this factor equal to 0. X equals 0 or x minus 7 equals 0. Yes, ma'am. Yes, I saw that, but that's okay. That'll put you ahead of the game for tomorrow. All right, ladies and gentlemen, let me tell you about homework.